Okay, today we are going to look at the distribution function method for the product and the quotient of two random variables. If you can remember what we did last time, we talked about how to find the density function for sum of two random variables and also the difference of two random variables. So we have already done that. Today we are going to look at how to find the density function using the distribution function method when our new random variable u is x times y, or the quotient x divided by y. Okay, so let's start with the product. So we need the density function of product of two random variables. Okay, so let u equals x times y. So we need to find the density of fu. Okay, so as the first step, let's find the cumulative density or the cumulative distribution function or the CDF of u according to the notation. That will be the probability capital U less than or equal to u. But we know u is x times y, right? So you can write it like this. Now if x times y is less than or equal to u, you can see that y will be less than or equal to u over x. And in this formation, x cannot be 0. Okay. Now if you choose x to be less than or equal to u minus y, in that case y should be not equal to 0, because you cannot have a division by 0 which is undefined. Okay, so let's stick with y less than or equal to u over x. If you draw the region for this inequality, what will happen? If you think about y equals u over x, okay, so you'll end up with a parabola for that function. And when you need y less than or equal to u over x, you can find this area will be above and beyond these two curves. Okay, you can try it by substituting 2 points in this region and see whether this inequality satisfies. Okay. Now let's try to find the limits for our integration. Okay. So our CDF will be, you have to integrate with respect to x and y the joint density of x and y. And the limit should be x times y less than or equal to u. Okay, so let's split the integration. So that is our second step. So if you integrate with respect to x first, x can go from negative infinity up to plus infinity. But y, it has a limit, it should be less than or equal to u over x. So y will go from negative infinity up to u over x. And you have to do the integration for the joint density of x and y. Okay, now let's do the change of variable as usual in order to get rid of this complicated limits of the integration. Okay, so let's introduce the new variable v to be x times y. Okay, and then your dv will become absolute value of x over dy in order to support both the negative infinity up to plus infinity. So your dy will be dv over absolute value of x. Now we'll see what will happen to the limits. When y goes to negative infinity, what will happen to v? V will also go to negative infinity. Then when y goes to u over x, that is our limit, what will happen to v? So when you replace y with u over x, x will cancel out and v will reach u. Therefore, we can rewrite our function now. X will go from negative infinity up to plus infinity. And now our new random variable v will go from negative infinity up to u. And then we have to replace our y will be v over x, right? Our y will be now v over x. You can see that. and then we have dv over dx, that is our dy, and you have this dx as it is. Okay, so we did the change of variable now. Now the last thing, the step 3, that will be to find the PDF by taking the first derivative with respect to u. So if you want to find the PDF of u, you take the derivative d over du with, for our CDF. Okay, so you'll end up with d over du, the two integrals, and then the function. Okay. Now, if you can remember the fundamental theorem of calculus, we are applying that again. The outer integration, it is independent of u, so we can write it as it is, and then you take the derivative inside. So you have v going from negative infinity up to u, f x v over x dv over absolute value of x dx. Again, according to the fundamental theorem of calculus, what will happen? It is like the derivative and the integration balance, and we'll end up with only the outer integral. And when we apply the FTOC, what will happen? This u have to replace v with this u. Okay, so your final answer will be f of x u over x, and we have the dv and all the things will be gone. You'll end up with just dx over absolute value of x. So this is the density function of u when u is the product of two random variables. Okay, and in the similar manner we can find the quotient of two random variables. So let's try that also. So that is our fourth one. Now let's say let our u equals x over y. Okay, and you have to have the probability y equals 0 equals 0, or otherwise y is not equal to 0. Okay, so y cannot be equal to 0. If y equal to 0, the probability of that y should be equal to 0, otherwise these derivations cannot be defined. Okay, so let's start with the definition again for the CDF. Our FUU will be the probability u less than or equal to simple u, which is the probability x divided by y less than or equal to u. Okay, so if you write the integration, you'll have x over y should be less than or equal to u, and you have the joint density. Now what will be the area? Now this is easy, just x over y, no intercept, goes through the origin, the slope is 1 over y, right? So you'll end up with a straight line that goes through the origin, and you need if you take the inequality y, this is our y equals x over u, and if you need the inequality y less than or equal to x over u, so that will be this colored area. Okay, so we identified the region. Okay, sorry, so that will be y greater than or equal, right? So if you do the other way around, so you'll end up with y greater than x over u, so this is the area. Okay, so let's write down our integration now. So this will become, we can leave the freedom for y to move over negative infinity up to plus infinity. Then the limits of x will be right? The limit of x will be x should be less than or equal to u times y. Okay, if x over y is less than or equal to u, you see that x should be less than or equal to u times y. So x will go from negative infinity up to u times y. And you have the joint density fxy. Okay, again we are moving to the change of variable. Okay, so I'm going to define my new variable v to be x over y. Okay, so as in the previous case, you will end up with the absolute value of y in order to allow negative infinity up to plus infinity. And when you do this change of variable, let's see what will happen to our x, the new limits. When x goes to negative infinity, v will also go to negative infinity, obvious. And when x goes to u times y, when x goes to u times y, y will cancel out and we will move on to u. Now we can replace these new limits and our CDF will be y from negative infinity up to plus infinity. Excuse me. Our new variable v will be from negative infinity up to u. And we have to change, excuse me. Now our x is what? If v equals x over y, our x is v times y. So you have v times y, comma y. And instead of dx, we have dv times absolute value of y. Okay, so yeah, dx becomes absolute value of y times dv. And we have dy outside. Okay, so the last step. So this is our second step. As the last step, we are going to take the derivative with respect to u in order to find the PDF of u. Okay, so let's do that. D over du, the integration from y negative infinity up to plus infinity, v from negative infinity up to u, f by comma y, absolute value of y, dv dy. Again, we are applying the FTRC, but first let's take this. The derivative inside the first derivative because y is independent of d over du. So here's our next step. Sorry, this should be just v times y. Excuse me. Again, we apply FTRC. Now what will happen? The derivative and the integration, they balance, and this u should be replaced. The v should be replaced by u. So your final result will be y from negative infinity up to plus infinity, f of u times y comma y, absolute value of y dy. So this is the density function of u, where u is the division of x and y. So now you know how to find or how to derive the PDF of the new random variable u, where u can be either sum of two random variables, the difference of two random variables, the product, or the quotient. As I always mention, it is good if you follow these steps one by one, or if you are very familiar with the variables and the change of variables and you have the idea on how you derive this, you can always use the final result because it is already proven. But make sure you use the proper limits for x and y. Depending on the question, you will be given the density functions of x and y with their limits, or maybe the joint density of x and y with their limits. So you have to write down your correct limits for y and x depending on the final expression. And according to that, you have to find the PDF. Okay, if you can remember the examples we did when we were adding two exponential random variables, the limits will be only the positive values, 0 up to infinity. So you have to find, or you have to use the correct limits for your integration of your final answer. And it will be always better if you can draw the region according to the given functions. And when you have the region, it will be very, very easy for you to figure out the limits of your x and y.